Today in Capechi's Corner, we're going to work on radical operations. In our first set of problems, we're going to work with addition and subtraction, and radicals work a lot like variables. You can only combine them if the radicals are exactly the same. So for instance, in number 1, I have 4 root 6 plus 10 root 6. Now because the root 6's are exactly the same, they're both radicals and they're the same value, I can combine what I have. So I take 4 plus 10, which gives me 14, and that root 6 stays exactly the same. So my final answer there is 14 root 6. In number 2, I have 8 root 3 minus root 3. So like I said, this is almost like taking 8x minus x. I would just subtract my coefficients and my variables would stay the same. So it's the same thing here. 8, this is really a 1 here. 8 minus 1 gives me 7 root 3, which is my final answer. Now, number 3, I have root 28 minus root 63. Neither of these are in simplest form. They both have perfect squares that go into them, so we need to do that step first. So 28, the highest perfect square is 4, so I get 4 root 7 minus, and root 63 and 63, square root of 9. 9 is the highest perfect square, so we have 9 root 7. So this simplifies to 2 root 7 minus 3 root 7. Now again, because my radicands, my number underneath the radical sign, are exactly the same, I can combine. So I end up with negative root 7. Now I'm going to look at some multiplication with radicals. So in number 1, I have the square root of 25 minus the square root of 36. Now both of these are perfect squares, so I'm just going to simplify that first. Square root of 25 is 5. Square root of 36 is 6. So I get 5 times 6, which is 30. And number 2, I can actually do this two different ways, so I'll show you both ways. The first thing I can do is the square root of 12 times the square root of 6. I can multiply the radicands underneath, which gives me the square root of 72. And from here, I can simplify. The highest perfect square that goes into 72 is 36, so I have 36 times 2. So my final answer is 6 root 2. Now another way if I want to do it, I notice that 12, the square root of 12, has a perfect square that goes into it. 4 goes into 12, so I can say the square root of 4 times the square root of 3, which gives me the square root of 12, times the square root of 6. So I have 2 root 3 times root 6. The 2 stays out front. Root 3 times root 6. That's going to give me the square root of 18. I'm going to multiply the radicands and then continue to simplify. So I have 2, 18 has a square root of 9 that goes into it, so square root of 9 times the square root of 2. So I get 2 times 3 root 2, which gives me 6 root 2. Now you can see our answers are the same in both methods. The first method was definitely a little quicker in this type of problem, but I wanted to show you what happens if you do a different method. And sometimes it takes a little longer, but in the end, you got the correct answer. In our next type of multiplication problem, I'm going to take root 2 times 3 root 6, and then root 2 times 10 root 2. So we're going to distribute. So I get 3 root 12. The number out front stays the same, the 3, and then I multiply the radicands. I'll do the same thing. Root 2 times 10 root 2 gives me, now I need my plus, so I have 10 out front, and then I know root 2 times root 2 gives me 2. So when I simplify, I have 3. Now 12 has a perfect square that goes into it. Root 4 times root 3. So I have 3 times 2 root 3, which gives me 6 root 3. 10 times 2 gives me 20. So my final answer there is 6 root 3 plus 20. Sometimes you see the answer with your whole number first, so it would be 20 plus 6 root 3, but either way is correct. And number 4, again, I'm going to multiply my numbers out front. My whole numbers, 3 times 4 gives me 12. And then I have root 7 times root 2, which gives me the square root of 14. Now 14 doesn't have any perfect square that goes into it, so that's my final answer. In number 5, I have the quantity of 3 root 2 squared. Now sometimes it's difficult for students to see this, so I like to rewrite it. So I have 3 root 2 times 3 root 2. So again, 3 times 3 gives me 9, and then root 2 times root 2 gives me 2. So my final answer there is 18. And number 6, this time I have a binomial. So I have root 8 plus 2. Again, root 8 plus 2, because my original problem was the quantity of root 8 plus 2 squared. Again, it's a lot easier just to rewrite it, and now I have a binomial times a binomial, so I'm going to use FOIL. So root 8 times root 8 gives me 8 for my first. My outside, root 8 times 2 gives me plus 2 root 8. My inside, I get the same thing, plus 2 root 8. And my last, I get 2 times 2, which gives me a positive 4. combine my like terms, so I have 8 plus 4 gives me 12, and then 2 root 8 plus 2 root 8 gives me 4 root 8. And at this point, I realize that 8 has a perfect square that goes into it, so I need to do that step. So I have 12 plus 4 times the square root of 4 times the square root of 2. So I have 12 plus 4, square root of 4 is 2, root 2. So my final answer is 12 plus 8 root 2. In our last problems for today, we're still going to be working with multiplying binomial times a binomial. So in number 7, again, I'm going to use FOIL. So I have negative 2 root 3 times root 3, which gives me negative 2, and root 3 times root 3 gives me 3. My outside, I'm going to get negative 2 root 3 times negative 5. So negative 2 times negative 5 gives me a positive 10 root 3. My inside, I get 2 times the square root of 3, which gives me a positive 2 root 3. And my last terms, I get 2 times negative 5, which gives me negative 10. Now I can combine what I have. Negative 2 times 3 gives me negative 6. So I have negative 6 and negative 10, which gives me negative 16. And then I have 10 root 3 plus 2 root 3 gives me 12 root 3, which is my final answer. Looking at number 8, we're still multiplying a binomial times a binomial, but we have some different radicals there, so we need to be careful. So again, I'm going to use FOIL because I'm multiplying a binomial times a binomial. 5 root 7 times 3 root 7, so 5 times 3 gives me 15, and root 7 times root 7 gives me 7. My outside terms, I have 5 root 7 times 2 root 2, so that gives me a positive 10 root 14. My inside terms here, I get 2 root 6 times 3 root 7, so that gives me plus 6 root 42. And my last, I have 2 root 6 times 2 root 2. So 2 times 2 gives me 4. And then root 6 times root 2 gives me the square root of 12. I have a lot of cleaning up to do. So 15 times 7 gives me 105 plus 10 root 14. There is not a perfect square that goes into 14, so I'm just going to rewrite that. I can't simplify that anymore. Plus 6 root 42, same thing. There's not a perfect square that goes into 42, so I'm just going to rewrite that. Plus 6 root 42. And my last one I can simplify because there's a perfect square that goes into 12. So this gives me plus 4 times the square root of 4 times the square root of 3. So the square root of 4 right here is 2. So 4 times 2 gives me 8 root 3. Now when I look, I can't combine anything else. I have 105, which is my whole number, and then I have root 14 and a root 42 and a root 3, so I can't combine anything else. So I'm just going to rewrite my final answer. So I have 105 plus 10 root 14 plus 6 root 42 plus 8 root 3. And the order here really does not matter.